Hello my champions, how are you all? Welcome back to the session. Today I'm here with continuity and differentiability part 3. Alright, so your unit tests are over. It took almost 12 to 15 days out of our preparation journey, but it was also very important to know where our strength lies, where our weaknesses lies, because after knowing all of that we can work upon it, right? So but now it is time to get back into a rhythm for the journey that we have ahead. Now when I say that the weaknesses or the strength that we observed while solving questions in the unit test, so for example, let's say I'm a student solving the questions, I might have felt in the examination that okay, I have made some silly mistakes. Okay, after coming out of the examination I might have felt that I made some silly mistakes that could have been easily avoided by disciplined practice. The word is very important. Practice is enough, but it has to be disciplined. If you are actually giving a punctual time set to yourself and practicing in that time duration, that's called disciplined practice, and of course with that silly mistakes can be avoided. Second type of mistakes that students makes usually is conceptual mistakes. For example, I don't know this topic itself, I skipped it, that's why the question came from here, not for that reason, but yeah, the question came from here and I cannot solve because I did not have that in my preparation backpack. Okay, so that you need to work on, that you can't skip the topics. Alright, the third type of mistake is the one that is I'm very that I feel very sad about it, because is those mistakes that you know the concept but still can't solve the question because there's some gaps in the concepts. Basically you needed some strengthening in that particular topic, you needed to revise it more, you needed to spend more time in the topic. If you have done that, you could solve that question that came in examination. Do you feel the same way? If you do feel the same way, that yes, this happened to me in the unit test, let me know in the comment section you were also feeling this thing. Okay, so now let's get back to our session. I think you are clearly understanding the session's agenda. Today we're going to learn exponential and logarithmic functions derivative. We'll see the nature of the functions, okay, the graphs, the domain, how different properties of these functions are used to solve questions in derivative. That's our agenda. Okay, but don't worry, all the highlights that I've given you, if you work on all these mistakes, the concerns I gave you, first one was silly mistakes can be avoided using disciplined practice. Second one was your conceptual mistakes, the chapters you skipped. Okay, and the third one was you needed strengthening in that particular concept or topic. If you work on all these areas of concern, I'm very much sure that you'll be among the toppers next year and will be joining top engineering colleges across Karnataka and India. Okay, so and your seniors are the also similar kind of student, right? These toppers are not because they've not made any mistakes. They are toppers because they also made mistakes like you, but they knew their mistakes, their weaknesses, and they worked on it a lot. They were very punctual, very disciplined in the process, and they got this outstanding result learning from us at our platform Diksha Karnataka. Okay, all these students are our students. They have studied from us, from our YouTube channel, and they got this outstanding result in KCET. You can be the next one if you are actually very much serious and studying from us, solving all the problems, relating and talking to us, asking your concerns, asking your doubts, coming to live sessions. If you follow the entire process, if you follow our work strictly, you will be among the toppers next year for sure. Okay, if you have any concern, let me know in the comment section. Right now it's time to start our session, sir. Okay, so today's session I'm going to solve some questions apart from these functions. Of course, the functions that we're going to have to explain and understand is exponential function and logarithmic function. Exponential and logarithmic function we have to understand today, with their properties, with their graph, with their domain, all of that. Okay, and how we use those properties in derivatives also. So that we're going to do with the help of total of 13 questions. Total of 13 questions I'm going to solve today. I might not give you any homework, but yeah, 13 questions I'm going to solve today to explain you the concepts of these two functions. Is that clear? Okay, so practice of 13 questions and your understanding of these two functions. That's the agenda of today's session. If it is okay, if you're ready, leave a comment right now. Ready, sir? I'll check your comments and reply to you. Okay, leave a comment right now. Ready, sir? Let's start with the first thing, which is derivative of inverse trigonometric function. Okay, why I'm writing it over here? I've already given you these formulas, but you're going to see they will play a role in the question solving today. Okay, so I've given you a list of all the derivatives of all 6 ITFs. For sine inverse, for cos inverse, for tan inverse, cot inverse, sec inverse, and cosec inverse. Okay, so please check 1 upon root of 1 minus x square is the sine inverse. Change the sign of that. If you change the sign of that to -1, what will happen? This will become derivative of cos inverse of x. So they are the same. just changing the sign of 1 to minus 1, okay, numerator, it becomes sin inverse and cos inverse difference. Let's go to tan inverse now. Let's go to tan inverse now. For tan inverse, the derivative is 1 upon 1 plus x square. 1 upon 1 plus x square. Now in this, if you change the sign of the numerator with a minus sign, it becomes derivative of cot inverse. Please check. Minus 1 upon 1 plus x square. The class notes you're going to get in the WhatsApp channel, so I hope you have joined it. If not, please join right now. After the session, I'm going to upload the class notes also. Now for cot inverse, I already explained you sec inverse. What will happen? You'll have x times of x square minus 1 with a plus sign. If you bring a minus over here, it becomes for cosec inverse. Of course, the first 4 are very much irrelevant for your syllabus. The last 2 are very rarely asked, but still it's good to know. If it comes this year, then what will happen? That's why it's simple formulas. Just remember, I've given you a list of all over here. Moving on. Now the first question on that. Now the first question on the application of ITF and use of the identities. Use of the identities you have learnt in PU1. In the PU1. Have a look. Cos inverse is this. Sir, how to break this question? For example, somebody who has not solved this question. If you have solved this problem, then you know how to solve it. Okay, you know which identity to apply over here and get it done. But if somebody has, never seen this problem and looking at this for the first time, how will they process this problem? They are good at this. They are good at derivative, but never seen this question. This can happen, right? Any student can be good at topic, but can come across a new question. So let's say this is a question for somebody who is good at derivative, but this is a new question for that student. How would you process that? How would you break this question? First thing is you look for what? The function outside. It is cos inverse. Our logic says that, sir, this can only work if I have over here cos. If I have cos terms over here, then my work will be easier. Then I can operate cos inverse with cos. They are inverse functions, so cancel the effect. All of you agree. Okay, but sir, this 2x by 1 plus x square, this looks something like tan. Remember we have a formula for writing tan inverse in terms of sin inverse, writing cos inverse in terms of tan inverse, like that. Okay. So if I substitute x value as tan theta, but sir, if you do that, you might tell me, so if you do that, this will become sin 2 theta. Okay, let me just write it for you. 2 times of tan theta upon 1 plus tan square theta. And yes, you are right, this is nothing but the formula of sin 2 theta. This is nothing but the formula of sin 2 theta. So if you're somebody who's concerned till this point, do one thing, write it, just write it for sake. Okay, so what is this question will become? Y equal to cos inverse of, this whole thing will transform into sin 2 theta. This much is okay. Now you might feel, sir, same thing, sin inverse cos inverse sin. But I can write sin in terms of cos. How? Complementary ratios, right? So we can write this as cos inverse of, write this sin 2 theta as cos of pi by 2 minus 2 theta. Now this is clear, right? Have a look. If you simplify this, you'll get sin 2 theta, and if you operate cos inverse on cos, they'll cancel each other. Now things are looking simpler, and I think you got the steps. So cos inverse of cos will cancel the effect on each other. The value of y will become pi by 2 minus 2 theta. Pi by 2 minus 2 theta. Is it over? No. You have to make some change. What is that? Because the given function has to be in the variable x for the derivative. Okay. So write theta in terms of x. If x is tan theta, means theta is tan inverse of x. Theta is tan inverse of x. Not alpha, but x. Theta is tan inverse of x. Okay. So replace that. Y equal to pi by 2 minus 2 tan inverse of x. We have learned the formula right now. Derivative of y is y dash. This will be 0, a constant. Pi by 2 is a constant, so 0 minus 2 as it is. Inverse of tan derivative. We just learned 1 upon 1 plus x square. Answer will be what? Y dash equals to minus 2 upon 1 plus x square. That's your final answer. Minus 2 upon 1 plus x square is the final answer. Please have a look. Okay, question number 1 is over. So this was just to give you some introduction of I2F also. We're going to use this kind of question a lot in the session today. So let's move on to now exponential and logarithmic functions. Exponential and logarithmic function, that's the agenda, original agenda today. Okay, great. So in this, the function will be of this form. You all know that. You have learned it in grade 7-8, I think, when you were for the first time introduced to indices. Remember, you had a chapter called indices. Which class was it? Let me know. 7, 8, or I don't think it's 8, 6 or 7, I think, right? So when you learned indices, you got to know this form, right? A to x. This a is called as base. This a power x, no? This a is called as base, and this x was what? Either index or exponent. Exponent. Remember this? Yeah. So this base and x will be there. This is the basically function form, the form of the function of the nature exponential. Okay. Great. So whenever this base is unique, unique means it can be e. Whenever this base is always e, then we call this to be e power x or natural, exponent. The base is e power x. Okay. So if the base of exponential function is e, that is a equal to e, then it is called natural exponential function. Natural exponential function. Okay. And otherwise we'll call simply common exponential function. If the base is anything other than e, if the base is anything other than e, it's called as common exponential function. Otherwise it is called as natural exponential function. Okay. Now the graph part. Okay. So the graph of exponential function, very beautifully is either this or this. Okay, this or this. Have a look. If you look at this part, what happens is, so this will be your base when this base here is more than 1. Base is more than 1. Okay, and this graph is for when the base is between 0 to 1. It can never be equal to 0, but between 0 to 1. When this base value is between 0 to 1, we get this graph, decreasing graph. When it is base value more than 1, we get increasing graph. In both the cases, it is never 0 or negative. This graph never comes below x-axis or never touches x-axis also. Okay, so let's move on now. We'll see the actual graph. I'll draw it for you. Let's see. Okay, so same graph you can see over here. Whenever the base is between 0 and 1, the graph starts decreasing in nature. Okay, but if you see the otherwise, if this base is more than 1, the graph nature is this. Okay, the graph nature is this. It keeps increasing all the time, and this point is nothing but 0, 1. In both the cases, this point is 0, 1. So whenever you take any value, exponent, check here, a power 0, what is the answer? Always 1, right? That's why this point will be passing through the y-axis at the coordinate 0, 1. Okay. One more thing. So what about natural exponential function, e power x? You'll have the same graph for e power x of this kind. This will be of this kind. Reason is very simple. Value of e is around 2.7 something. Okay, 2.6 something. So that's why it is more than 1. That base is e is more than 1. That's why you get the graph of this kind, not this kind. Ex will not be graph of this category, but graph of this category. Okay. Now check about domain. Domain of this graph of any exponential function is always all real. Check here. You can go from negative infinity to positive infinity. Hence, domain is all real. Domain is all real. But the range can never be negative or 0. That's why it is r plus. Range is r plus. The graph always passes through the point 0, 1 for a very large negative value of x. Now this point, very clearly you understand. This is talking about this side, okay, where very large negative values of x for a more than 1. Negative values of x, bigger value. What happens? The exponential function gets very close to x-axis but never meet it. Isn't this graph coming very close to x-axis but never meets it? Okay, same case for this. When a is less than 1. And for a very large value of x, for when x tends to plus infinity, very large value of x, what happens? The y tends to 0 but never becomes equal to 0. Y tends to 0, almost comes close to x-axis but never becomes 0. Okay, that's the property of the exponential function that I've discussed it over here in both the cases. Is that clear? Let's move on. Now we have logarithmic function. just inverse of exponential function. Okay, see, this was your exponential function, right? This was your exponential function. A par x equals to b is a function, right? So if you take logs now on both sides, so let's say I have a function defined like b equals to a par x. Take log on both sides. What are you going to get? You'll get this as log of the number b. Log will also have base in it, okay? This same base will come here, equals to x. So log of b, how we read it? Log of b with the base a is equals to x, okay? Please check. Log of b with the base a equals to x. These two are actually inverse of each other, okay? These two are actually inverse of each other. If you take exponential function over here, let's say if you take base a over here, both sides will become what? So if you write like this, a power log of b a equals to a par x. This will get cancelled, you'll have simply b left. So you can interchange between the exponential and logarithmic function, okay, because they are inverse of each other. Alright. The function from the positive real numbers to real numbers is defined as, that's how the log function is defined. This represents your domain. So what is the domain over here? Domain is all real but positive real numbers. Not 0, not negative, okay. And how about range? Range is what? All real numbers, okay. So if we try to use these two and draw the graph comes as this. The graph comes like this, okay. The graph comes like this, and this point will be what? This point will be 1, 0. This point will be 1, 0. We can also have this category as well. We can also have this category as well for the a value between 0 and 1, and for this a value more than 1. This is for a value more than 1. This is the value of a between 0 and 1, okay. A value between 0 and 1. What is a here? A is the base of log. So yes, very beautifully, base value exists in the case of exponential function also and in the case of logarithmic function also, okay. So a value is there. This a represents what? Base, okay. And when this base becomes equals to e, when you write base with the value e, what happens? This is called as natural log. This is called as natural log. For example, I am talking about log of the variable, let's say y, with the base e, okay. This becomes equals to simply ln y. It's called as natural log. With the base is e, it's called natural log, or if it is 10, it's called as common logarithms. It can be any other value also, but usually we use 2, a as 10 or a as e. Have a look. Let's move on. Some simple properties I've given you over here, okay. Now this curve you can see here, when a value is more than 1, the graph goes like this, increasing. Explained to this already. When a value is between 0 and 1, the graph comes like this, and this point is what? 1, 0, okay. This point is 1, 0. Again the function is defined like this, y equal to log of x with the base a. This is decreasing in nature, this is increasing in nature. Please check. Increase the value of x, y also is going up. Here, increase value of x, y comes down. Remember, in the case of exponential function, the graph never touched x-axis. But in the case of logarithmic function, the graph will never touch y-axis. Here, it will never touch y-axis. Here also never touch y-axis. Gets very close, but never touches it. Okay. So basically, in this case, you can see when x goes to negative infinity, I wrote here x, no, I'm talking about y actually. So when y goes to negative infinity, x tends to 0 but never 0, okay. Here also, in this case, when x tends to 0, y goes to plus infinity, okay, plus infinity. Please check, when x is going to 0, y goes close to plus infinity but never reaches it, never reaches it. Of course, you can't reach infinity, right? So let's read it out. Domain is all real, positive real numbers. You don't have any, you don't have even 0 also here. Please check. 0 is also not there. Domain is only positive real numbers, and range is equals to r. Okay. The graph always passes through the point 0, 1. Sorry, this is wrong. 1, 0, not 0, 1. 1, 0. Okay. My mistake. This is typing mistake. 1, 0. For x very close to 0, I already explained you this. Close to 0, what happens to the graph? Y goes to infinity, negative infinity. Okay. In this case, positive infinity for both the cases. Alright, so let's move on. Now if you see the graphs of exponential and logarithmic function, no, actually they are reflection of each other. I can show you example. So if you see the graph of, let's say, e power x, this is my e power x graph, right? And what is the graph of exponential logarithmic function? This line is called as y equal to x line. Y equal to x line, this is the curve for e power x, y equal to e power x. Then the log curve will look like this. This is my y equal to ln x, y equal to ln x, okay? The curves y equal to ln x and e power x is mirror image about the line y equal to x. Why they are mirror image? Because they are inverse to each other. Because they are inverse to each other. All the inverse functions will be mirror image like this only. Remember? Okay. So this is clear. I think I've taught you that in my ITF session when I was drawing the inverse trigonometric graph with the help of sine inverse, or so with the help of sine graph. Okay. So the inverse functions are always what? Always mirror image about the line y equal to x. Okay. Very much clear. Okay. This is not a track or road. This is y equal to ln x. This is y equal to e power x. Two different curves. Okay. All right. So let's move on. Okay. Some properties, some formulas, some identities for logarithms, which is very, very useful. We'll see in the questions right now also. Okay. Log of nm with the base a is given as what? This is called as your product rule. Your product over here becomes summation. Log m plus log n. Okay. This is a very important formula. You can keep changing the bases. Let's say I start from log of a with the base b. I can write this as log of x with the base b. Okay. Then one more time I can write log of y with the base x. I can go one more time. Log of t with the base y, and I have to write finally log of b with the base t. Okay. Not b, a actually. One second. Log of a over here, not b. Log of a. Have a look. So this is how we can keep changing the bases. See, started from, we had a to x, right? And we are going ae ex, ae ex, same way. We had b to a, right? So bx xy, yt ta. So basically the first one should be b and the last one should be a. You can keep changing like this the bases. Okay, great. You can also, this is the quotient rule, m by n, they are in the division, write it as log m minus log of n. Yeah, this is m by n, right? So it becomes log m minus log n with the same basis. Now this is the power rule. The power comes as the coefficient n log m. Okay, this n was the power of m, right? So n, the power comes in front as the coefficient of the log. Log m with the base a remains as it is. If you have e and log e, if you have e and log e x, so they are the same function, right? See, log of the e and with the exponential function of a, e only, it becomes x. I can take another example. Let's say it is log 5 with 5 here of x. Answer is always x only. But if it is, let's say, log of x with the base 5 and this is 4 power this will not be equal to x. Okay, they have to be same. These two have to be same. Here we have log of x with the base 5 and this on the exponent of 4. Okay, but it will not be equal. In this case, not be equal to x. I hope this is clear. Okay, some properties to remember. Next, few more. You can use log of x as log of x with the base a as log x by log a with the same basis. What I mean by that, let's say if I have log of 5 with the base 2, I can write them both as log of 5 with the base 10 divided by log of 2 with the base 10, or any number. I don't want to write 10, no need to write 10, I can write a anything. I can write any basis, but they have to be same. A over here, a over here. This can be any base a, this can be also any base a. Okay, great. Now if you have log of m with the base n, log of m with the base n, I can write the reciprocal form but reverse the numbers. So we'll have log of n with the base m. Let me change this and write a number over here. Okay. Let's say this is 4, this is 5. Okay, they will become 5, 4. Have a look. 5, 4. Okay, great. Log 10 to the base 10. Log 10 to the base 10 is always 1. So basically log a to the base a. Log of a to the base a is what? 0. Okay, log a to the base a is 0. But log 1 to base 1 is what? This is not undefined, sir. This is undefined. You will never call that base is 1 log 1. Okay, sometimes they will ask you, if somebody asks you, your friend, is this 0? Say don't. No, not possible. Log 1 to 1 is not 0 because log with the base 1 is not defined. Please check everywhere I have written, there is nowhere a is equal. This is also a greater than. Please check. This is representing a is greater than, not equal to. Okay. In this case also I have written a is less than but never equal to. So a cannot be 0, a cannot be equal to 1. Okay. In all the cases, please write this, very very important. A can never be equal to 1. The base of the log can never be equal to 1. Okay. The base of the log can never be equal to 1. See, they've always mentioned over here a not equal to 1, n not equal to 1. So base can never be equal to 1. That's why if they are saying log 1 to 1 equal to 0, not possible. They can give you, in an MCQ, pick the wrong one or pick the right one. Choose the right option or choose the wrong options, incorrect or correct option. This is always incorrect. This is always incorrect, not defined. Very much clear? Okay. So one more thing I want to tell you before I move on. Extra information. If I have here log of m with the base n, log of m with the base n, there is a power of m, let's say it is a, and power of n also, let's say it is b. So I am saying that for the base and for the value, both has powers. Okay, there is a formula for this also. So this a will come in front, right? Yes. So right here a log of m. What about the base? Base will remain as n and this b will come in the denominator of the coefficient. So the value that is there, the index of the m will come as the numerator of the coefficient, whereas the power of the base is n over here, that will come as the denominator of the coefficient. That's why it is b. A by b log m to the base n. Okay, it's very important formula. I'm telling you, it's very very important formula. Question can be asked on this in your CET examination. Okay, even in JW also. Okay, so this is very very important for all of you. Y equal to e power fx, then dy by dx is what? E power fx times derivative of f of x. Basically, you want to differentiate this first, which will remain as it is, then differentiate the function as the index of e. Okay. Then we have y equal to a power fx, then dy by dx equals to a power fx log. What is this? Differentiate this. There's a formula for this, right? I'm going to tell you that later, don't worry. So, yeah. This will come as it is, then ln of a will come. When this is written as log, no, it represents base is always e, okay? Otherwise, it will be stated as 10 or something else. I'll show you that. Do not worry, I'll show you that. So, basically, I'm talking about this. If you have a power x derivative, okay, is nothing but a power x ln a. A power x ln a. So, if you have, let's say, a power fx, what is going to be the derivative of this? It will become a power fx, again ln a, and of course derivative of x, fx. So, f dash of x. Please check. In this case, derivative of x is 1, right? That's why not written it over here, but for the fx, derivative will be f dash of x. That's what was the formula mentioned to you over there. Let's solve the question now. Question number 2. Can you do it? Of course, very easy question. So far, if you have any concerns, you have to leave that in the comment section, because now I'm going to move on to solve the problems. Clear, all of you? Please leave your concerns in the comment section right now. Now I'm moving to solve your problems. Sine tan inverse of e power x. Sine tan inverse of e power x. There are too many functions over here. First function is sine, then we move on to the tan, and then e power minus x. This derivative will include, of course, chain rule, right? So starting from sine, let's take this function to be first. Y equal to sine tan inverse e power minus x. Excuse me, e power minus x. All right. So y dash will be given by what? The derivative of sine will become cos. So cos of this remains as it is, tan inverse e power minus x. This is done. Now next move to tan inverse. Okay. So for that we'll have 1 upon 1 plus whatever is the value over here, that's the square. Okay. Then last one, derivative of e power minus x. E power minus x will remain as it is. Okay. And that value, if you differentiate minus x, you're going to get what? Value of derivative of e power of the derivative of minus x will become minus 1. Derivative of minus x will become minus 1. Okay. Great. So my final answer will be like this: y dash equals to minus e power minus x, this minus sign come in front, so minus e power minus x, cos of tan comes here, tan inverse actually, and e power minus x, okay, and this divided by 1 plus, excuse me, 1 plus e power minus 2x. Power to power gets multiplied, right? So 1 plus e power minus 2x. This is plus, okay? Done. Question is solved. That's your final answer. That is our final answer. Very simple question. So derivative of e power x is what? E power x only. Derivative of e power ax is what? E power ax, and then derivative of ax. How much is that going to be? Simply a times of e power ax actually. E power ax. Great. Moving on. Question number 3. Now we have ex e power x square plus e power x power 5. I have taught you this question. This is your homework. This is your homework. Please solve it. Okay, same formula will continue. E power x as it is. You will have over here e power x square times of derivative of x square and so on. Okay, do it. Solve it and cross check your answers. I have given you answers already. I hope you got it right. Okay. Question number 3 you are going to solve. Very simple question. Question number 4, use of quotient law. Okay, again very simple, not difficult at all. So we got to differentiate cos x first. We'll get what? So I'll write this first statement. Okay, derivative of cos x, log x remains as it is, comes plus sign, sorry, minus sign, no, quotient rule, here minus sign over here, not plus sign, my mistake. Okay, and keep this time we're going to keep cos x as it is, differentiate log x, okay, divide by log x the whole square. This is my y dash. Okay, that's my y dash. This is the formula I've written over here. Now I'm going to solve it. Derivative of cos x is minus sin x. This will become as it is, so log x. For this we'll have minus cos x as it is. Derivative of log x is 1 by x. And over here we have log x of whole square. Take minus sign common. Okay, and take LCM also over here. We get here x sin x log x plus cos x, and that x you've taken as LCM will come in the denominator. It will become x log x the whole square. That's my y dash. Check the simplification. I have taken x as the LCM. This will multiply over here x sin x log x, and this will become simply plus cos x because I have taken the minus sign outside, and we have this x which will come in the denominator, so x log x the whole square. That's my final answer. Have a look. Okay, 3 steps, not more than that. 4th is done. Question number 5 now. Differentiate log e power mx minus e power minus mx with respect to x. Do not worry, I have more questions coming your way in your session number. I think there will be session number 4 also. There will be another question session for CET, for JEE mains. So there are a lot of questions coming your way. So yes, I am taking some easy questions over here, but we're going to build on that. Do not worry. Let's solve it. So log of e power mx minus e power minus mx. We're going to differentiate log first. So write y dash equals to, this will remain as it is, e power mx minus e power minus mx. Agreed? Okay, this is not alpha. That's x, okay. This is x. Now what? The derivative of this part. So right here as it is. So e power mx minus e power minus mx, the derivative. So y dash, what I have? E power mx minus e power minus mx. Okay. Now this is 1 only. Let's differentiate this. You're going to get this answer as m times of e power mx. I just explained you this. Right? E power ax if I have, we did it over here, no? E power ax came as a times of e power ax. Over here, please check. Same fashion, I'm going to get over here as m times of e power mx. Okay, over here we'll have what? Minus m times of e power minus mx. Simplify. So the numerator is what? Numerator is m times of e power mx plus m times of e power minus mx divided by e power mx minus e power minus mx. If you want, we can take m common and remove this m from here. You can remove this m from here. That's your answer. That is your answer. Okay. E power mx plus e power minus mx upon e power mx minus e power mx. Answer is multiplied with m also. That's my value of y dash. Have a look. Simple question. Question number 6 now. Differentiate e power x log of sine 2x. Now the question level keeps increasing. So if you solve this question, we're going to use what? We're going to use, of course, chain rule. But before that, we're going to use product rule also. Okay. So let's do that. So y equals to e power x we have. Logarithm is also there. But inside that we have sine 2x. So let's use for the first, we're going to use product rule because we have two functions, ex and log. Right, ex and log. Sine 2x is there, but that is part of the chain rule. Okay, so we have only two functions over here, not three. There is no log x into sine 2x. They have only two functions. Okay, ex and log of sine 2x. So differentiate e power x, it remains as e power x, and log will be kept as it is. Log will be kept as it is. Okay, and next what we're gonna do? Take a plus sign. Okay, take a plus sign and differentiate log sine 2x now, keeping e power x as it is. What I get? 1 upon sine 2x, derivative of log, and for derivative of sine 2x we'll have cos 2x. One more time differentiate 2x also to get that value as 2. Please cross check my answer. I am taking e power x common over here. This will become log sine 2x, the first term, and this will be what? 2. This number 2 will come, cos by sine will be cot 2x. Your option is what? Your option is e power x log sine 2x over here plus cos 2 cot 2x. Option B is correct. Question number 6 is over. Question number 6 is over. Very simple question. Just follow the product rule. Product rule, and then we have chain rule applied over here together. Okay. These two. Can we move on to the next question? Question number 7 now. Question number 7. Okay. Before that we have logarithmic differentiations. We'll see. So sir, we have already, didn't you teach that, sir? If y equal to ln x, derivative of y will going to be 1 by x. Yes, you taught that, sir. If you have y equal to log of x with the base a, derivative of y is going to be 1 upon x ln a. So you taught that, sir. You have taught that. Then what is this? So this is when we're going to use logarithmic properties, that formulas that you have, to obtain a result of a complicated question. For example, if you have two functions, let's say written like this, fx to power gx, fx to power gx you have. How do you solve this kind of question? So this might be sine, this might be tan inverse, sine and log. There can be different combinations, right? Then how do you solve this question? And let's say this is equal to given as y equal to this format, y equal to fx to power gx. So what you do simply is take log on both sides. So this will become log y, this will become log y, and this side will become what? Log of this. Log of fx to something power will come in front as the coefficient, the property we learned right now. So this will become gx log of fx, gx log of fx. Now from here you can do the derivative. So basically see, log of y, gx log fx. I'm going to erase this and show you how we differentiate this kind of given situations. So whenever you have to deal with functions given in terms of product, powers, basically exponents, or ratios, basically quotient, okay, then you're going to use the logarithmic differentiation to get rid of them, the complex form. Okay, so let me differentiate this. So you're going to differentiate log y, it will become 1 by y. It says log, it means natural log only. Until unless they gave the base as a or something else, then only you're going to treat the second form. This is the first form, second form. If they mention the base, then you're going to treat the second form. Otherwise, always treat as first form, okay. So 1 by y you get for this, and of course derivative of y will also be taken, so y dash you'll get, correct, now log of y derivative is 1 by y, but derivative of y is what, y dash, this is dy by dx. On this side you're going to use what, product rule, differentiate g, you'll get what, g dash of x, keeping log fx as it is, log fx as it is, plus sign will come, keep gx as it is, and differentiate log, so you'll have what, f of x in the denominator. Is it over? No. This is the derivative of log. What about fx? Do that as well, chain rule, okay. So f dash of x. Is it over? No. You're looking for derivative, right? So write this y dash over here and move this y on this side. You'll get y times of, I'm not going to write this fx gx like this, simply write g dash f, okay. So what we'll have, g dash log of f, okay, plus g dash by, sorry, not g dash, g by f, excuse me, g by f times f dash. That's my final answer. Y dash equals to y g dash log f plus g by f f dash. So some of you might be complicated, this question might be complicated, but do not worry, when I take example this will become very, very simple. But right now understand, I'm not using anything else than the formula, the derivative of log and product and chain rule. Product and chain rule. Let's move on. This is a differentiation of logarithmic form. What about exponential form? We can solve. Remember this question was given like this, y equal to, okay, I'll write it over here. We had y equal to f power g. Same thing, no, over here. Same thing in the previous slide also. Y equal to f power g. So we'll not write fx gx. I understand. I hope you understand, right? F represents fx, g represents gx. So what we can do is we can take exponent on both sides. Okay. If you do that, so what will happen? It will become what? Okay. So I'll take exponent combination. So I'll take e power g. I'll take. Okay. So e power g log f with the base e. Please check. E power g log f with the base e. This e and e will become what? This e and e will cancel each other. It will turn out to be g f power g only, right? Correct, no? If I write this as e power log e f power g, same thing, right? F power g. It's not fg, it's f power g. Let me write this again. 1 second. Yeah. This is f power g. Log of f power g. So g come in front. That's what I've written over here. All right. Okay. I want to solve it on this side. I want to solve it over here. So I have this expression now. I can write it again. Over here, y equals to e power g log comes log of f with the base e only. Basically ln of f. Okay. Differentiate this. What are you going to get? Y dash. This will remain as it is. E power g ln f. Ln f, same thing. And this time what is going to happen? Multiply. So basically differentiate this part. Okay. The product of g and log. Differentiate g first. You'll have g dash log of f remains as it is. Plus sign will come. Plus sign will come. Keep g as it is. Differentiate log of f. You'll have what? G by f. Differentiate of log will g by f, and derivative of f will become f dash. Okay. One last step. Y dash become equals to e power, this whole thing, e power ln f power g. E ln will cancel each other. So I'll have the final answer over here. This will be as it is only. I'll have the final answer as simply f power g dash ln f plus g by f f dash. Have a look. Same thing. Y is what? F power g. Y is f power g. So y times of g dash log f plus g by f f dash. This is y only, right? This whole thing is y only. So y times of g dash ln f plus g by f f dash. Same thing. They are the same thing. Okay. So you can use the result of applying log on both sides, or if you want to use exponential function, you have to apply like this. If you like to use exponential function, you have to apply exponential function like this. Exponential function like this, or log function is easier actually in this format. Okay, this is clear. Log function I think is easier for all of you. If you want, you can use exponential function also. Now we have product question. We have cos x, cos 2x, cos 3x. How do you solve it? First you take the function y equal to, excuse me, yeah, y equal to, you will take cos x, cos 2x and cos 3x. They are all given in product. They are all given in product. So whenever you have this kind of situation, in the product format, the functions are given power format, or they are given in the form of quotient. What is the rule? Apply log on both sides. Take here log y, take here log of cos of x, cos of 2x, cos of 3x. Okay, derivative of this will become what? 1 by y. Log y will become derivative 1 by y. Derivative of y is y dash. For this, you have to use the formula first, right? So we'll use the derivative later. Right now the formula. So log of cos x plus log of cos 2x plus log of cos 3x. The whole thing derivative. We're going to do in the next step, no problem. But yeah, formula of log a b c, log a plus log b plus log c. Okay, log a plus log b plus log c. So we have here log cos x becomes what? This becomes cos x comes in the denominator, and derivative of cos will be minus sine. Okay, here also minus sine 2x by cos 2x. Here also minus sine 3x by cos 3x. Okay, in this case we'll have 2 also over here and 3 over here as well. Why is here 2 and 3? Derivative of 2x will be 2, derivative of 3x will be 3. That's why. Okay, now rest is simplification. We get y dash equals to, this y will move on this side, so y dash equals to y times of, have a look, minus tan x minus twice of tan x, okay, and minus thrice of tan 3x. Actually there is a mistake, this would be tan 2x actually, tan 2x, and this, if I take the minus sign outside, no, I can take minus sign common, so you'll have tan x plus 2 tan x, 2 tan 2x and 3 tan 3x. That's your answer. Y dash equals to y times of, what does y means? What does the y mean? Y will become what? This one, cos x, cos 2x, cos 3x. Okay, tan x, 2 tan 2x plus 3 tan 3x. Y dash equals to minus y of that. If you are thinking that let's multiply the LCM of cos x, cos 2x, cos 3x, you'll have that in the denominator, that will cancel this in the numerator, because numerator has y in it. This is nothing but y, right? Numerator has this, sir, over here. If I multiply this as y, that will cancel the LCM of cos x, cos 2x, cos 3x. Don't do that, because what will happen, it will become sin x, cos 2x, cos 3x plus sin 2x, cos x, cos 3x. Then sin 3x will become cos x, cos 2x. There is no point of writing all of that. This is the simplest form you can write. Just simply represent, just replace this y with this value. That's all. Question number 7 is over. Question number 8, let's solve now. Differentiate with respect to x, sec square x to the power 1 by x. So write this first, y equals to, write this as sec of x power 2 by x. How come? Power rule, right? Power gets multiplied. Power rule, power gets multiplied. That's what written. 2 times of 1 by x is nothing but 2 by x. 2 by x. What is the next step? Take log on both sides. Log of y equals to, this will come in the front, so 2 by x as the coefficient, log of sec x. Log of sec x. Next is the derivative. Log of y derivative is what? Continue, 1 by y dash, 2 by x if you differentiate, you will have minus 2 by x square. Derivative of 2 by x. If you are not sure, do the derivative. Derivative of 2 by x square is 2 by x is minus 2 by x square. Keeping log sec x as it is, log sec x as it is, plus 2 by x as it is, differentiate log sec x. You'll have 1 by sec x, and derivative of, what is it? Sec x. You'll have sec x tan x, right? Sec x tan x. So this is cancelled. Okay. So I have y dash equals to y times of minus 2 by x square log sec x, okay, log sec x, and this is nothing but plus 2 by x tan x. Something is common, right? We can take minus, okay, plus 2 by x common, okay? No, 2 by x square we can take common. 1 second. Check this out. So we have over here 2 by x square, we have 2 by x. I'm taking 2 by x square common, so we'll have 2y upon x square. We'll have 2y upon x square common, which gives me what? Which gives me over here minus log sec x, okay? And this will become what? This x square is taken common, means I have to multiply x over here, correct na? Take, if you multiply x to x square, what are you going to get? 1 by x. That's why it is only 1x in the denominator. So x will come, I'll have here x tan x. X tan x. I think that's your answer. That's my final answer. 2y x square, 2y divided by x square minus log sec x. Okay? Yeah, this is the answer, option A. Option A is correct, sir. Y value is this, sec x power 2 by x. This whole thing is y value. This is the y value. This is value of y. So 2y upon x square, x tan x minus log sec x. Option A is correct. Please cross check. Question number 8 is over. Now question number 9. Okay. So we have y equal to log tan x by 2. Find the derivative dy by dx. How do you solve it? Very simple. Take derivative y dash as, first you differentiate log. Simple use of chain rule will do. Okay. So we'll have a 1 by tan of x by 2 over here. Okay. And differentiate tan, you'll have sec square x by 2. Differentiate x by 2 also, you'll have 1 by 2. As I said, simple application of chain rule. So we have 1 by tan x by 2, sec square x by 2, and 1 by 2. Okay. Right, 1 by 2 over here. This becomes what? This becomes cos, sine over here, right? Tan is there, no? So sine by cos. So we'll have over here sine x by 2. The cos can go up, right? Cos x by 2. 1 by tan is cot, right? You can write this as cos by sine. Okay. And sec square will become what? Sec square will be 1 by cos square x by 2. Okay. I've written the 2 already outside over here. This will cancel one of the cos's. I get 1 by 2 sine x by 2 and cos x by 2. I get this as 1 upon sine 2 times of x by 2. The formula is there, right? Sine 2x formula, sine 2 theta formula is there, no? 2 sine theta cos theta, that one. So 1 by 2 sine x by 2, 2 and 2 cancels. I get simply as 1 by sine x, which is nothing but cosec x. Cosec x. Option is C. Option is C. Question number 9, option C is correct. Question number 10, let's solve now. Question number 10. Y equal to log of x plus 1 upon root of 1 plus x square. Root of 1 plus x square. We have to find a derivative. Again, same thing. We have to use the chain rule only. Let's do it here. Y dash will be what? 1 upon x plus root of 1 plus x square. This is clear. Okay. Next will be what? You have to use chain rule. To differentiate this, you'll have 1 over here. X is 1. And this will become what? 1 by 2. 1 by 2 root of 1 plus x square. Correct? That's the root of 1 plus x square derivative. Derivative of 1 plus x square in the root means power is 1 by 2. So derivative will become what? 1 by 2, 1 plus x square, 1 by 2. Right? because the power will become 1 by 2 minus 1, that comes in the denominator. So root will come in the denominator. Is it over? No. Differentiate this also, 1 plus x square. You'll have 0 plus 2x. Okay. So this 2 and this will cancel. You'll have 1 by x plus, chain rule application, just be patient, 1 upon x upon root of 1 plus x square. This is good so far. All in the product. Okay. Let's take the LCM on this side. We get x plus root of 1 plus x square. If you take LCM over here, what do you get? You get 1 plus x square plus x plus x. Have a look carefully. This thing and this thing is cancelled. My answer becomes 1 upon root of 1 plus x square. 1 upon root of 1 plus x square is the final answer. This is my final answer. Please cross check. Got it? Question number 10 is also over. Question number 11 now. Just few questions to go and we'll complete our session also. Differentiate e power log to log x times log 3x. Same approach right here, y equals to e power log of log x, right, times of log, excuse me, there's a mistake, this is simply x actually and this is in the denominator, not denominator, in the base over here. So log x and log 3x. Alright, check this, e and log will take the inverse out, e power log will take the inverse out, correct? Now their inverse function, e and log. So we'll have what? We'll have simply this as y equal to log of x times of log of 3x. They'll be cancelled over here. This 2 will be cancelled over here. Only log of x will be left. Now you apply log on both sides. So many logs, yes. So many logs, correct. Log of log x times log 3x. Separate this property of log, the product rule. We have log of log x as one term plus log of log 3x as my second term. Okay. This is log y. This is log y. Next, you're going to do what? Derivative. What's going to happen? Differentiate log of y. You'll have 1 by y dash equals to. For this, you'll have 1 by log x and derivative of log x. So we get 1 by x. We get 1 by x. Okay. Plus, same thing over here, 1 by log 3x. 1 by log 3x. And we get what? 1 by 3x times 3. Because log 3x derivative is 1 by 3x, the derivative of 3x is 3. So this 3 and this 3 is also cancelled. I'll repeat myself. Log of log 3x derivative is 1 upon log 3x. Log 3x derivative is 1 upon 3x and derivative of 3x is 3. Let's conclude now. I'm getting this y dash equals to, moving this y on this side, I get y times of x is also common, I think. X is also common. So I'm taking this y over here and x is also common, so taking this x also out. And so far I have 1 by log x plus 1 by log 3x. Beautiful. Y upon x, check this out. LCM we're going to take log x, log 3x. This will be log 3x plus log x. Correct? If you take LCM, you're going to add this, right? Log 3x over here, log x over here, making equivalent fraction, you know all of that. Okay? Now check this. This y and this is cancelled. How come, sir? So y value from here. This is same as y. Log x, log 3x is same as y. Okay? So they will be cancelled. What is left now? We have two values over here. So my y dash equals to x as it is. Log a plus b, log of two log sums becomes log of product. So 3x into x. Log of a plus log b becomes log a into b. What is the answer? Log 3x square by x. That's my derivative answer. 1 second. That's my answer. Have a look. So option becomes what? Option B is correct. Option B is correct. Question number 11, option B is correct. Okay, option B is correct. Have a look. Question number 12 now. Let's have a look. Class notes, you need to solve this question again. So download the class notes in the PDF format and then cross check this and try giving a fair attempt to this question. This one is very simple. Derivative of e power x, y equal to, if we have e power x, we'll have what? We'll have e power x as it is, and then you're going to differentiate this value, will remain as it is. That's my answer. Option A is correct. As simple as that. Option A is correct. Last question of the day. Okay, let's solve this. Cos of log x the whole square with respect to x. Okay, y equal to cos of log x the whole square. Derivative. Derivative will become, cos will become what? Minus sine of log x the whole square. We'll use only chain rule over here. We'll use only chain rule over here. Next will be for log x. Sorry, next will be log x the whole square. That will become what? 2 log x. This was for log x the whole square. Next will be what? For log x. So that you'll have 1 by x. For log x will be 1 by x. That's my final answer. So minus 2 log x sine of log x the whole square divided by x. Option. Okay, option. So minus 2 log x sine of, option D is correct, no? Yeah, option D is correct. So this completes our session on the derivative of the functions logarithmic and exponential. You can see we have solved extensive amount of questions from both the topics. If you still have some queries from these two functions, let me know in the comment section. I'll come back with a session to help you out with that. That is it for today. If you are new to the channel, please subscribe to the channel, because we are here to deliver quality content, serious content for your preparation of CET, JEE and your boards. Okay. Any other thing you need from us, just let us know in the comment section, and that will be all for today. I'll see you again very soon. Till then, take care. Bye bye.